Okay, I built this little circuit here that I found somewhere off the internet. Yeah, it's supposed to be an adjustable constant current source, based on a 317 regulator, right? And I'll save you the suspense. It does work. Now, I use the exact same values you see here, and my circuit is identical, except that I'm using a TIP31 right now. I haven't used a 2N22 yet, but I'm going to here in a second. But here's the build right here. That right there is our 317. And here is the TIP31, and there's a little potentiometer, and there's that 47 ohm resistor, and then I have the output coming down, and right now I just have it short circuited, right? And I'm keeping it to 8 volts because this is putting out a lot of current, so I want to keep it brief. That's why I'm short circuiting. If I put this through my box here, it'd burn it out. So, but at 8 volts, I'm kind of thinking about reducing the voltage on it, because I should be able to go down to, like 6 volts or something. Let's do that instead, keep these things cooler, so I get a little more run time with it. And if I turn it on, it's about 274 milliamps right now. Oh, I guess I got my camera out of focus. Well, actually, it's pretty good to see what's going on here. But this is probably what you're more interested in, is seeing what happens when I adjust the adjustment terminal here on this potentiometer, which is difficult to do. Okay, going up 300 milliamps, 400, 500, 1.1 amps is where it kicks out. Going back down. Back down to the original setting or so. So, again, that's about the low end of this particular. Damn, that thing's regulator in particular is still hot at this level. So, but yeah, so anyway, the circuit does work, with this, but again, I'm going to try to stick this 2N22 in there. I'm going to have to rearrange things, so bear with me. But yeah, you'd want to definitely use heat sinks and shit like that, but again, that's kind of a pain in the ass. Alright, so with the 2N2222 in there, I set my current limit at half an amp, because that's about the limit of the transistor. So it does work, but its bottom current is 137 milliamps, but I can keep adjusting it, straight up there until it hits the current limit, but let me adjust it back down. And again, it's really the regulator that gets hot, because the transistor's only got 1¼ volts across it, so it's still not going to dissipate a whole lot of heat, but still it can be enough. So yeah, it tops out at 800 milliamps, which is more than the transistor will handle. So according to the article anyway, but it does work. But the part values are going to need to be chosen differently. But the principle seems sound. I since I can't get it to work within a reasonable current limit, with the values listed, I'm kind of reluctant to run any kind of long-term, reliable. If I can get it down like 10 milliamps or something, I might leave it running overnight, right, and see how stable it is, as a current source, because that would be interesting. Because a 317, has a band gap reference in it, so You know, that's why that's 1 1 1 1/4 volts output. That's its band gap reference, that it's exposed, you know, almost directly to the outside. I mean, most of those regulators have a band gap reference, but most of them are modified to get to like 5 volts or 12 volts or whatever. So, you know, you got some other circuitry involved, so it may not be as accurate of a source as a 317. So if you want to, you know, more or less temperature stable band gap reference, a 317, you know, and you're in a pinch, you know, a 317 is not a bad choice. And if you keep your current low on it, you know, like 10 milliamps or something, it, you know, should be really quite stable. But, you know, so at any rate, you know, like I said, this is an interesting little test. And, you know, I actually originally had my TIP 120 or whatever plugged into it. You know, when this one didn't seem to work, the TIP 1, you know, TIP 31. And, you know, you couldn't adjust it more than, you know, like 15 milliamps, you know, and it wouldn't put out more current than 15 milliamps. But that's not surprising, because it has like a voltage, you know, a VCE voltage drop, you know, about 2 volts, you know, even when saturated. So, I mean, you know, and this has got to be limited to, everything's got to function on this regulator within 1.25 volts. But I was going to say, you know, you could do this same circuit with like a, you know, 7805, and, you know, then you got more headroom, then you could use a Darlington for it. But again, you know, these regulators are pretty limited to current anyway. I mean, a lot of use scenarios, like if you wanted a variable constant current source, which is what this is, that's the whole idea, you know, is how to get a variable constant current source out of a regulator without having to use a high wattage pot, you know, which can be hard to come by, you know, to get this halfway decent current out of the thing. Well, using a transistor is a great idea. I came up with the same idea myself, but eventually found this article on the internet, and, you know, and sure enough, I guess it does work. I've been wanting to actually look at this thing for the last 2 or 3 years, because I was considering it, but I knew it was something that was experimental, so I really didn't have the tools to evaluate it very well at the time, at least not without it getting carried away. But I just knew it probably wasn't going to suit my needs anyway. It was just part of a solution at the time. But, you know, these 317 and, you know, these 3-terminal regulators usually have pretty lousy thermals, you know. So like a 7805, unless you're supplying it with like 7 or 8 volts, you know, over its dropout, not 7 or 8 volts over its dropout, but I mean 7 or 8 volts, you know, including its dropout voltage, you know. I mean, you got to keep it really low if you want to even get anywhere near 1 amp out of it, because the thermals are so lousy at, you know, 5 or 6 degrees centigrade per watt. It's hard to get rid of the power, you know. These things just have lousy thermals, and 317s are no exception. So, you know, it kind of limits you in most applications to running it at 100, 200 milliamps, and that's with good, decent heat sinking. So, you know, like you're putting, you know, like 30 volts across the 317, right? And you might do that in a constant current source circuit, you know, so you get a, you know, good, you know, headroom on how much, you know, of a load you can hook to it, you know. You would want it to actually have a high voltage, but all that voltage has got to be dropped across the regulator. So if you got it set to a high enough current, you know, you're not going to be able to do it. I mean, this would probably just be limited to about, you know, half an amp or so in situations. That's in an indoor environment, basically. So, you know, especially if you're driving up, you know, to 35 or more volts, you know, up near its limits, you know, it just, you know, you could probably get away with a transistor like this, because again, no part of that transistor is ever going to have more than 1 1/4 volts across this thing unless it's malfunctioning. So, you know, it doesn't have to dissipate a lot of wattage, and this thing's supposed to, if you read the article, you know, it's supposed to get up to, you know, like half an amp or so. So, you know, as it's the 2N22 limit. But anyway, you know, my point is that, hey, it's an interesting circuit, but you're going to have to use different values if you want to get lower current. And, you know, I'm not surprised, you know, because a lot of this looks a little hokey how it's set up. So, you know, certainly I don't, you know, because you would think, you know, setting that wiper clear over here, you know, would be, you know, across the emitter collector. It's almost like shorting the emitter, I mean the base and emitter, you know, of the transistor, which should turn it off, right? But apparently not. It's not even turning it down that much. So, you know, but that's probably more because of the potentiometer than anything. It mustn't have a, you know, mustn't go down to a very low resistance. Some of these don't. Some of them won't go down to anywhere near zero. So, anyway, especially a little single turn pot like this. But anyway, yeah, it's an interesting little circuit. So, you know, you might look at it. It might come in handy for some application. You know, because again, it's still based around a 317 regulator. So because of that, you got some fair amount of complexity trying to keep the thing stable. And in theory, the transistor, once you set the current and let it, you know, sit there for a little while, you know, will reach some sort of thermal equilibrium. But, you know, there probably will still be variations in this thing's beta as your temperature changes. So I would expect some variations, but again, you know, without getting a lot more carried away with this, I may investigate this later because it's a cool little circuit. It might be interesting trying to think about cobbling it together in some form with different component values, obviously. But you know, it might have some you know, some interesting uses. I mean, I did make, you know, I came across on Cassian TV. They have like a plan for a low, you know, a milliometer based on a 317. And I built it, and that motherfucker works. I mean, it's actually impressive how well that worked. You know, just go to Cassian TV on YouTube, and you know, or look them up on the internet, and you know, look up, you know, milliometer or something like that. You should be able to find the, you know, the video. But you know, I did build that son of a bitch. Hold on, I'll see if I can find it for you real quick. Yeah, here it is right here. So it's fuck you. You know, it's DIY milliometer, you know, from Cassian TV. So, you know, the link's rather cryptic, but, you know, basically here is the design I built. So, you know, that's, you know, because I actually put Kelvin probes on the thing, and, you know, a little meter, you know, bought from Amazon, because, you know, Kelvin probes are a must on something like this. But, you know, here's basically, you know, the arrangement. You know, you got to calibrate it, you know, with something, you know, but, you know, it's pretty darn stable, you know, once you calibrate it. It's not bad, you know. Generally I had it powered from like 20 volts or so, but you know, that's the circuit board I built. You know, and this is a picture of what you'll see in their video. You know, 13 ohms is a little tricky to come by, so a potentiometer is going to be a better choice so you can calibrate it. But anyway, you know, you can give that video a watch, and you know, again, it's Cassian TV. They got some interesting stuff on their, you know, the little YouTube channel, and apparently they got like a site or something too. So, but at any rate, you know, just enter Cassian TV DIY milliometer. You know, that'll get you there. So anyway, that ought to cover it though. So cheers. I wanted to say, you know, in this regulator, there was a pretty good reason to actually do it the way they're doing it, because keep in mind, these actually have band gap thermally stable voltage references in them, so that means the current source itself they set up can be a lot more stable if you did it with a JFET, for example. But again, I got the JFET idea out of data sheets actually, you know, for voltage regulators. So, and it does work, but this might give you an advantage if you really need a much more stable current source, because, you know, the current, you know, the voltage, you know, still, you know, is set based on this potentiometer, right? So, you know, if that fluctuates due to temperature or something like that, in theory, your current is going to fluctuate a little bit as well. Whereas the more stable the reference, you know, the current going through here, the more stable your output current will be. So So there's that, because I was going to say, you know, that one way that I've done it too is actually by making, you know, again, down below the ground level here, you know, and I've got this idea out of magazines, actually, electronics magazines, you know, where they'll use, you know, a BJ, you know, like an NPN transistor and set it up as a voltage follower, you know, with a voltage reference supplying it, you know, but yeah, that makes a decent enough little constant current source, and it works too, you know, and then you can use whatever power part you need, you know, in terms of its current capabilities, but again, you know, keep it to 5 milliamps or so, hey, you'll be fine. And that works, but that is one reason to maybe do it this way, if you need something that's extra stable. So, you know, but you could maybe use one of those little TO92 base 317s to do it, or even use a different, you know, TO based transistor, but this would, you know, work just as well, and you don't have to have that negative of a power supply with it. You know, again, minus 5 volts is plenty to get it below ground. So, but I'm just saying, there is that, and you only need this. Again, keep in mind, if you're trying to go down to 0 amps, if you don't mind it being, you know, 10 milliamps, you know, you don't need this. You know, you don't need to reference this to a negative voltage. You could just tie it to ground. You know, if that's all you need. But, you know, or you can do, like I said, like that circuit, you know, that you know, I talked about earlier, you know, so, you know, again, there are a lot of options on these things, you know, for higher levels. You know, in earlier videos, you know, I discussed the little 2 transistor references, which are good for low current levels and low current references, and, you know, you might be able to modify them for higher current, you know, with using power transistors and shit, and to some extent that might work, but again, they're still not fully temperature stable and everything else, you know, but something like even one of these is going to be more temperature stable just because it's got that regulator involved. That helps mitigate some of the variability here. And like I said, this is still, you know, under a constant power situation. For any setting you'll have it. So, but at any rate,